15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us. This is Space Nuts. It's all about astronomy and space science. We talk about what's happening on Earth and in heaven and everywhere else, because we've just got such a wide scope of places to investigate and talk about. I mean, it's limitless, really. And on the program today, we will be discussing some work that's been done through the University of Cambridge, where they may have accidentally stumbled across evidence of dark energy. Now, we know it exists. We know it makes up a substantial part of the universe. We've just never been able to actually identify it directly. So have they found dark energy? Have they found evidence of it? I mean, we know it's there because of the influence it has. So we'll look into that. We're also going to talk about a 2,200-year-old observatory in Peru. It was only recently discovered around 2005, and it still works. It still works. Quite extraordinary. Plus audience questions. We'll be talking about whether or not you can watch light move through the universe. If you're at the right place at the right time and a star suddenly appears, could you watch the light moving across the universe? And a bit of a tongue-in-cheek question about flat Earth theory. Also looking at the effect on non-moving objects in the universe. Can anything stay still? That's a good question. And a question about time and gravity, all on Space Nuts this week. I'm your host, Andrew Dunkley, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Good, Andrew. How are you doing?
I am quite well. How are you?
Yes, very well indeed, thank you.
Coping with lockdown still?
Yeah, more or less. We are still locked down, that's right. But
well, at least this gives us something to do.
Yeah, it does. Actually, lockdown, the antidote to lockdown is that we've got 3 beautiful planets in the night sky at the moment in the early evenings. Venus, actually Mercury's there if you get it in time before it sets in the early evening, but also Saturn and Jupiter. I had the telescope out at the weekend having a look. They look stunning.
Yes, I've seen quite a few photos that people put on the Space Nuts podcast group Facebook page when they go out observing. So quite a few of our listeners have got telescopes and they've taken some amazing shots lately. So
indeed,
it's pretty impressive. And I believe Jupiter took another hit the other day.
Yeah, I was just going to mention that. That's right. And that was captured by a number of amateur astronomers taking videos of Jupiter, and they got this bright flash not very far from Jupiter's equator. It was recorded by several astronomers, so it wasn't a glitch in the, detector or anything like that. Great stuff. It was something big hitting Jupiter's atmosphere. Probably a small asteroid, something like that.
An asteroid or a comet? Maybe a comet?
Yeah, maybe a comet.
Who knows? Yeah. They might figure it out. They might not. But it was quite a flash. Now, let's move on to our first topic, Fred, and that is dark energy. We get so many questions about dark matter and dark energy, all because of the mystery surrounding this stuff. Dark energy, we talked about how it's probably not well named, but they've been doing some experiments through the University of Cambridge, and it looks like they might have stumbled across the detection of dark energy. It's not been absolutely confirmed, but they might have, tripped over it by accident because they were trying to do something else.
They were, that's right. So this is an experiment at the Xenon 1T facility, which is at Gran Sasso in Italy, and it's a bit like an astronomical telescope. It's built as a facility that can be used by many astronomers, and they all come and get their 2 or 3 nights or whatever it is on the telescope and then go away and work out the results. And a facility like this is similar in the sense that it has access by various different researchers. And in this case, as you've said, these researchers are from the University of Cambridge, and they've got, basically the bottom line, Andrew, is that there are some unexplained results that have come from this experiment. What these scientists were looking for was evidence of extremely rare interactions between particles of dark matter which makes up about 27% of the mass energy budget of the universe, compared with about 5% for all the stuff we can see. So they were looking for, so we think that dark matter is some species of subatomic particle, which we haven't yet identified, but that it may, on very rare occasions, interact, i.e. bash into a normal matter particle, hydrogen or carbon or whatever. The idea of this Xenon 1T experiment was to try and detect such collisions. But what they found was a background signal that didn't match any of the predictions for dark matter, but actually was more like the kind of signals that you might expect from dark energy. And that's intriguing, because dark energy has always been seen as the harder problem to solve. It's, 68% of the universe is dark energy. It's basically an energy of space itself. That's what we believe, that's causing the expansion of the universe to accelerate. But subatomic physicists, they think in terms of dark energy as being carried by particles. For example, gravity, which is in some ways the opposite of dark energy, because it's a pulling together of matter, and we do understand gravity. That we don't have a subatomic model for it properly yet, but people speculate that it's carried by gravitons, subatomic particles that carry the effect of gravity. And there may be particles that carry the effect of dark energy, and that's what they think they've detected.
You know, it's really funny, because when I was reading the article, a thought popped into my head, and I thought, is it possible that dark energy is simply anti-gravity?
No, it's not. And the reason for that is dark energy is everywhere. And the effect of gravity is well understood. It follows the inverse square law, so that, as you move away from it, the gravity drops off with the square of the distance. Dark energy is not like that. It's everywhere. So it is different, but its properties are similar in the sense that if gravity is an attractive force, if I can put it that way, dark energy isn't. It's a repulsive force, but it's not. So in
that way, they seem to be opposites to each other in that respect.
That's the thing. But it's not anti-gravity, because to have gravity, you need matter, and we don't seem to need matter for dark energy. It's just there.
Okay. Wow. And they're going to do some tweaking of the experiment, as I understand it, to see if they can now hone in on this, because it's not absolutely certain that this is what they've discovered, is it?
No, that's right. And these things never are. They're what you have to do, you get something that looks suspicious, and then you, exactly as you said, you home in on it to try and really kind of tease it to death to find out what's actually lurking there, whether it is a real observation or something different. And a classic example of that was a couple of years ago. There were 2 experiments at CERN that gave results that suggested that a subatomic particle had been discovered that might lead to the proof of supersymmetry, which is another theory that doesn't have any physical observations behind it at the moment. But both of those observations, even though they were done on 2 different instruments, they disappeared. When they looked more closely, the signals weren't there. And I should explain that this is all measured in terms of probability. What the probability is of this being real. And for it to be reported as a real effect, it needs a very high probability indeed.
Well, they're going to try and replicate this. And the part of the story that really made my eyes pop out was, we think we might be able to get an answer within a decade.
That's pretty soon for this sort of thing.
Oh, yeah.
Yep.
I guess so. All right. Something to watch with interest, and may slow down the number of questions we get about it.
Well, it will be
going forward.
Yeah, wouldn't it be great if we could pin down dark energy? And what will be even greater is that really will be new physics. So it's beyond the theory of relativity, and that could open up all kinds of possibilities for our
couldn't it? Wow. Yeah. Okay, now let's talk about this Peruvian observatory that was discovered in 2005 and has hit the news again. What's the story with this one, Fred?
Yeah, this is something very, very close to my heart, Andrew. And the reason is that Marnie and I led, I think, the first tourist expedition to this site back in 2007. It was our first science tour. And we had one of the archaeologists who was responsible for the discovery, Ivan Gatesi, Peruvian scientist. He came with us. So we got a first-hand look at it. And honestly, it is such a haunting place that it's stayed with me ever since. If anybody's interested in following up my experience in that, I think it's chapter 3 of Star Craving Mad. My book about astronomy travels is devoted to this place and what it was all about. So what we're talking about is this is about 370 kilometers north of Lima. It's in the Casma Valley is the river valley name, and this is a place where a river flows down from the Andes, and of course it comes and goes very strongly with the snow melt in the Andes. And huddled around the river are fertile areas with little villages in them. But also, so you only have to walk 300 or 400 meters away from the river and you're in desert, and it's proper sandy desert, the real thing. Yeah,
I thought from the video it looked really desolate.
It is utterly desolate. But at the same time, 2,300 years ago, and in fact, at least 1,000 years before that, because there are other artifacts there, it was a thriving centre of population with probably a religion that demanded huge constructions, and there's evidence of plazas on a mammoth scale, 0.5 kilometre across, and other structures having been there. But in the middle of all this, there's a hill which runs north-south, pretty well exactly north-south, almost like a Hog's Back type hill with a curved top. It's 200 or 300 meters long. And on top of that are 13 towers built to very exact proportions. They're damaged now. Earthquake damage tends to knock the corners off structures like this. So most of them have got some earthquake damage. But those towers have actually been known for many decades. But it was only in 2005, as you said, and actually published in 2006, that Ivan Gatesi and another well-known archaeoastronomer, that's the ancient astronomy, who's at the University of Leicester, Clive Ruggles. And I was actually talking to Clive last week because he did a talk for us. A great speaker and a great scientist as well. So Ivan and Clive figured out that what these towers were for was a calendar, essentially. So what you've got is they identified 2 places, one to the east of the row of towers, one to the west of it, where if you observe the sun rising on one side and setting on the other side, those towers act as a kind of calibration of the horizon. So the sun comes up slightly differently every day, and by looking at where it crosses those towers, you can see exactly what the date was. So an enormous amount of effort went into understanding that and building it, and we're left with this, this record of a civilization about which we know very little. They're well pre-Inca. The Incas were in the 14th, 15th centuries, 15th, 16th, I think, actually. But this is a different civilization. What is really striking, though, is that you could, if you make your observations carefully, you could work out what day it was within a year. Now, they didn't have a modern calendar then, but they would have perhaps worked out the dates by when the sun crossed this, they crossed the different towers. And what it seems to have been all about, Andrew, and this is the slightly gruesome part of this, was ritual warfare. It was about the gods telling them that they had to go and beat up the neighbours because they'd get the water if they didn't. And they had these ritual wars which were absolutely scathing. They were ghastly, gruesome. There's another temple not very far from Chanquillo, which we also visited, that's full of murals, carved murals that look as though they've been made yesterday. This is more than 3,000 years old. But it shows
Amazing.
Dismembered bodies, and it's just very accurate and really grim to look at. So that was what it was all about, which is bizarre to our understanding, but it's an extraordinary thing. The reason why it's in the news again, Andrew, to get to the point, is that it's just been given World Heritage listing.
So it should.
Yeah, thanks to Clive and other people. It really needs protection. It's such an iconic site.
Magnificent. It must have been a thrill to get to see it.
Unbelievable. Yeah, unbelievable.
Amazing. All right. You can learn more about it by jumping online. There's lots of articles, and it's easy to find. Yep. I think the University of Leicester has published a story about it as well.
Indeed.
So, go and dig that one up. You're listening to Space Nuts. My name's Andrew Dunkley with Professor Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.